Now let's learn about a very important concurrent collection in Java, which is BlockingQueue. Since it's quite commonly used, we will try to learn it in somewhat more detailed manner. Imagine a blocking queue to be like a conveyor belt in a factory where items are placed and taken off. In Java, a blocking queue is a data structure which allows multiple threads to safely put items onto the queue and take items off the queue, and this is done in concurrent manner. There are two aspects of blocking queue. So the first part is the blocking aspect. The term blocking means that if a thread tries to take an item from a queue which is empty, it will be paused or blocked until an item becomes available. Similarly, if a thread tries to add an item to a full queue, it will be blocked until the space becomes available. The second aspect is the uses of the queue. So the blocking queue follows the first in first out principle, meaning the item that was added first will be the first one to be taken out. Now let's talk about the blocking queue interface. In Java, the blocking queue interface is the parent interface to a few other interfaces and the concrete implementational classes. So this is the parent interface, which is the blocking queue, and the two such interfaces which extend this blocking queue are blocking DQ and transfer queue. So this is also sometimes called as blocking deck or DQ. So whatever you wish to call, you could call it. Now coming to the blocking deck. So blocking deck is a double-ended queue that blocks threads when it reaches its capacity or becomes empty, thereby facilitating flow control between producers and consumers. It provides methods to access the queue from both the ends in a thread-safe manner. Due to its double-ended nature, the performance characteristics of blocking deck may differ from those of blocking queue, especially in the scenarios where there is a contention for access to both ends of the deck by multiple threads simultaneously. Key takeaway from the implementational perspective here is that it provides access from both the ends in a concurrent manner. Regarding the transfer queue, it's a specialized queue where producers can block until a consumer directly receives an item. It extends the functionality of blocking queue by providing a method called as transfer. What this method does is, it allows one thread to transfer an item directly to another waiting thread, potentially avoiding the need for blocking. If there are no waiting threads, transfer behaves like put and blocks until there is a space available for the item. Transfer queue ensures a strong handoff coordination. What does this mean? Let's understand this with an example. Imagine a factory where one worker produces items and another worker packages them for shipping. The producer worker can directly transfer the produced item to the packaging worker without waiting if the packaging worker is ready to receive it. If the packaging worker is busy, the producer worker waits or blocks until the packaging worker becomes available to receive the item. This direct mechanism can improve the efficiency in certain scenarios compared to a traditional blocking queue. So now let's learn about the major implementations of the blocking queue. The first one on the list is array blocking queue. It implements a bounded blocking queue and it is backed by an array data structure. The next one is the linked blocking queue. So this one implements a bounded or unbounded blocking queue backed by a linked list. The priority blocking queue implements a blocking queue that orders elements based on their natural ordering or according to a specified comparator. Then we have delay queue. What it does is it implements a blocking queue of delayed elements, where an element can be only taken out when its delay has expired. It is particularly useful for scheduling tasks to be executed after a certain delay or a specific time. The final one is the synchronous queue. This implements a zero capacity blocking queue where each insert operation must wait for a corresponding remove operation by another thread and vice versa. So based on your requirement and uses, you could use either of these implementations. But for most practical purposes, the uses of array blocking queue, a linked blocking queue, or a priority queue should be good enough. Now let's have a look on the blocking queue operations. So these are the certain operations which are supported by the blocking queue. Put method adds the specified element E to the queue if the space is available. If the queue is full, the operation blocks until the space becomes available. Next is the take method. It retrieves and removes the head of the queue. If the queue is empty, the operation blocks until an element becomes available. The third one on the list is the offer method. What this does is, It adds the specified element to the queue if the space is available. It returns true if the element was successfully added or false if the queue is full, as opposed to the put method which blocks until the space is available. Poll method retrieves elements from the head of the queue. It returns null if the queue is empty. It does not block the queue if the queue is empty, as opposed to the take operation which blocks the queue until an element is available. The peek method retrieves but does not remove the head of the queue. It returns null if the queue is empty. Some of the above methods also provide overloaded signatures which allow you to pass timeout values as well. So I suggest that you explore the BlockingQueue interface. There you will find all the variations of the major methods which we have described here. So all the implementations of the blocking deck interface have functionally similar methods which provide these operations on both the ends. As an exercise, you could try exploring the interface and the implementations to understand them better. So now let's have a code demonstration which will showcase the uses of the BlockingQueue interface. In order to demonstrate the uses of the BlockingQueue interface, I'll be creating this class inside the concurrent collection package. Let's call this as BlockingQueue demo. Here is what I'm planning to implement. It will be of some capacity and there would be a couple of threads. One thread would be a producer thread. Then we can have a couple of more threads. For example, let's say 2 threads as the consumer threads. And once we start the threads, then the producer thread should be able to produce or write data to the queue, and consumer threads should be able to consume from the queue. So let's implement this. So let's start by having the queue capacity. Let's call this as queue. Next we can have the BlockingQueue itself. So let's declare that, and we want to put an integer value in the BlockingQueue. Let's call this as a task queue, and we are going to make use of the implementation of array BlockingQueue. Let's pass the capacity, that is the queue capacity, and let's start by implementing the main method. First on the list would be the producer thread. Here in the producer thread, what we will be doing is we will be iterating for a certain amount of time and then putting that number to the task queue. So let's implement that. So we have a try block. Let's have a catch block as well. We will have an interrupted exception. So let's put this for now. And now coming to the try block, we will have a loop which is running from 0 to 20, 0 to 19 rather, or maybe let's change the numbers from 1 to 20, and all it does is it puts this number to the task queue. So let's call put, and the value would be I. Let's print a message, task produced I, and let's have a sleep timer for let's say 100 milliseconds. So this is essentially the task generation time that we are having here. And now that we have written the producer thread, let's write the consumer thread as well. So let's have the first consumer thread. Let's call this as consumer1, and let's rename this to producer. So what this consumer thread does is it consumes from the task queue infinitely. So let's implement that. So let's start by having a try block. Let's have a catch block. Let's have an interrupted exception, and let's throw this one as a runtime exception. So while true, what we are going to do is we can retrieve the task which we have in the task queue dot tick, and then we will call a method. Let's call this as process task. So let's pass the task and the consumer ID. So let's now implement the process method before implementing the second consumer. So private static void process task, then we have the int task, then we have the consumer name, and let it throw the interrupted exception because I wish to provide some sort of sleep in this particular method. So first we start by printing a message that task being processed by consumer name, and then print the task. Then we will try to sleep this for 1000 milliseconds. So the idea is that in real world scenario as well, when you will be processing a task, that will involve certain time, right? So here, since we have a pretty much bare bones implementation, what we are going to do is we are going to provide some sort of sleep, and that will mimic the processing time, which is 1000 milliseconds in this case. And now once we have done the processing, we can print the message, the task consumed by consumer name, and this is the task. And now we will be implementing the second consumer thread as well. So let's call this as consumer 2, and we will have a similar kind of implementation here as well. So let's copy this one really quick. And what we are going to do is everything remains the same. So this is going to run infinitely. It's going to extract out the task from the task queue. Process task remains the same. It's just that we change the name here. So now let's call this as consumer 2, and everything else remains the same. So now let's start the threads. So producer.start, consumer1.start, consumer2.start. So I think this should be it for the implementation side of things. Let's run this code and see how is the output like. So as you can see, that task being produced is being printed by the producer method, and then task being processed by consumer 1, and task consumed by consumer 1. So we had introduced some sort of sleep, right? So during that time another thread takes over, that is the producer thread, and it's going to produce. So basically task being produced, so task ID with 2 is produced and kept in the queue. Then this task is being consumed by consumer 2 as soon as the task is available in the processing queue, right? So this is the way in which the producer is creating tasks and pushing to the queue, and the consumer on the other hand, which we have a pair, consumer 1 and 2, they are pulling the queue and they are taking out from the queue and working on that and consuming the tasks in the task queue. So you could try to implement it yourself. So using the BlockingQueue, we have implemented a simulation wherein we are writing to a thread safe concurrent data structure, which is the BlockingQueue, and we are able to operate on the data structure using multiple threads, that is the producer thread and 2 consumer threads. So you could go through the code one more time and try to get a hang of it if it's not very clear. So as an exercise, you could go ahead and explore these classes and try to come with certain use cases and implement those use cases using these classes. So this will really help you with your understanding of the uses of the BlockingQueue in the Java.